time since we have a lot to accomplish today. Just want to welcome you all and thank you all for joining today. We are now going to be rolling out today our next two AI use cases, roadmaps that we had worked on while in our April club study at Bridgestone in Nashville. I believe most of you know me, but I'm Pam Walter from MAPconnected. Just wanted to highlight there our next coming events, which is August 12th, where we will launch the fourth and fifth AI use case from Tavant and Upstream Security. We are organizing a technical assistance center new executive roundtable discussion group. If there's anyone that is would like to let some people in your organization know about that, that will be a launching in August with an initial meetup. So far, OEMs, there's 4 OEMs that are confirmed to join that. We will, this year will just be an August meetup and a meetup at the annual conference in October, and then also into next year, commitment of 2 to 3 quarterly meetups, and then the annual summit. We're also had a lot of interest from the events that determine warrantability survey that had been contracted from one of our OEM members. So we're looking to do some further benchmarking from the survey results. And for those members, I will be shortly getting out your tickets, ticket links, so you can register for the annual summit, and with a special note to October 23rd, which will be a new day on connected fleets and service repair and lifecycle optimization. Just reminding everyone to the My Warranty Network is now live and launched. Anyone that had a previous membership or online profile, just log in with your business email and just ask to reset your password to gain access. Anyone that's new, there is a free option for you to get involved, as well as different package options. But those are annual packages that give you an opportunity to participate in start discussions and threads to encourage member interest. We have articles from the community in their opportunity to send a direct text message and messages to people. But there also is the opportunity for you to reach out to our featured sponsors to ask them questions as well as submit projects. Just really quickly thanking our 8 AI sponsors of this think tank for this year. As we're all done, we probably will be rushing off to our next meeting, but I just making it clear that we have developed 5 AI project roadmaps. They are ready to go. We are will be we already rolled out Circuitry AI, which is hosted by Ted Danner here online today, the Sd-ize and SAS, and then August, the last two, but they are ready to go. All we need is a champion to take these on and bring them in as a proof of concept. We've done all of the work. We just need someone to accept it. So just wanted to start off with introducing today. The discussion for the next half an hour will be from Zach Dawson, Director of Global Warranty Quality Claims from Cummins, and Sd-ize Managing Director, Matti Korvinen. They worked directly on this project in Nashville and created this roadmap. And you're going to hear from them that they actually have already also run POCs in this particular area. So just lead it off to both of them. So perhaps, Matti, just start off with a short introduction to yourself.
Yeah, so very briefly, Matti Korvinen, spent whole my working life in consulting, close to 40 years, and out of that maybe 25 years in after sales and warranty areas. I spent 23 years with Accenture, where I had the responsibility for a number of warranty-related engagements, both in consulting, doing diagnostics and operating model work, development work, global implementations, but also responsibility for multi-year outsourced engagements where we were doing the warranty claim validation or early warning analytics as an outsourced service to our clients. And after retiring from Accenture 10 years ago, I was the co-author of, you see there is the book cover page on the screen, a book on the warranty fraud management with Ilkka Töyrylä and Bram Murthy, pretty much sort of summarizing the experiences we had at that stage. And I am based in Finland, which I understand the location and the sort of the time difference might be a concern to some of you, but I would say that I have worked with foreign clients regularly, and the previous AI in claims management POC was actually done 100% remote to a European client. Whilst that was doable, I think that it was not optimal, so that I would recommend a couple of trips to the US if we get forwards with this project. But, Jack, please go ahead yourself.
Yeah, thanks, Matti. Good morning and afternoon, everyone. I'm Zach Dawson. I'm currently the director of the claims operations at Cummins. I've been working in warranty for about 15 years, but my current responsibility is kind of all the warranties and claims across the global product offering at Cummins, and I'm excited to be here and work through this POC and talk about it with Matti.
Thanks. Okay, this is pretty much summarizing the discussion we had in Nashville in May, and there we had also Brad from Toyota and Mike from Synchron participating in this initial brainstorming and shaping session. But here you see the challenges and the goals, most likely fairly familiar concepts like the limitations of the rules-based validation, the long lead times from claims to decision, high volume of claims through a manual or semi-manual operation, the outcomes depending very much on individuals, meaning that some people do it very well, some people do it average, and some people do it not that well. So inconsistent validation results, slow adjustments with changes in the environment, and of course then the waste, abuse, and fraud. And the goals we stated for the whole concept was like to reduce manually adjudicated claims by 50%, so that if you would currently validate automatically 60% of your claims, then the target would be that, okay, we would come to 80%. and then give just recommendations to the remaining 20%. And that sort of helps out in shaping the business case for the operation. And definitely targeting significant lead time reduction in the claims process and cost savings, both in terms of the fraud reduction as well as improved dealer satisfaction with being more consistent in the claims process. But so, Jack, when you were starting this journey with Cummins, what was the sort of the main motivation for you to explore machine learning in warranty claims processing?
Yeah, so I mean, there's a number of things, and you touched on a few of them, like cycle time of claims. Everyone is probably aware you have legal requirements to pay a claim in a certain time frame. Also, customer expectations, always want their claims paid as quickly as possible. Also, another thing for us, our businesses are expanding and markets are expanding, so the claim volume is increasing, and I have a fixed operations myself, or at least challenges in getting additional resources. So that drove it. Variation is another. We had some negative feedback from our dealers that, you know, two otherwise similar claims may get handled differently by different people. That was kind of a minor one, but the biggest one, really, the eye-opening thing that convinced us there was opportunity, is that we look at the claims that we had people reviewing, and we found that 50% of the time we're looking at a claim, say, yep, that's a good claim, and we're going to pay it. And we, you know, kind of concluded that's not the best use of anyone's time. And I'd add that those claims that someone looks at just to confirm that it's good, they're not spending the most time there. I mean, that's not the most complicated scenario, so you may not, you know, reduce your resources in half, but you'll definitely improve your throughput significantly. The biggest one is that we don't want people looking at claims that are good.
Okay, Pam, please, let's go to the next slide.
I'm trying. There we go.
Right. Yeah, here we go. Yeah. So this is pretty much the structure of the POC I was involved with, so that starting with the input, that was just a claim data file. So 100,000 claims. And then in the actual POC, we had these 4 steps in the middle, so that this analyze and transform data means first, like, converting the claim data into a format that machine learning algorithms can use and understand. And then on the other hand, sort of a set of analytics to understand the big picture on the warranty and pick up any inconsistencies and correlations and outliers in the warranty data that might impact the machine learning model. And sort of after the fact, I can say that I would have spent more time in this phase than I did, but I was very eager to get to my hands on the machine learning models and sort of see what comes out of there, and then sort of those inconsistencies were visible in the machine learning results, so that maybe spent a bit more time. So after the fact, I would have spent more in the analyze and transform phase. And then, Pam, if we still go to the next slide. Yes, no, not this previous one. This one. Here on the right-hand side, you see like the structure of this training and testing the machine learning model, so that we split the claims data into like training and testing parts, and the data included the claims and the validation results, sort of that is this approved or rejected or approved with some modifications. And then with this, the model is sort of learning that, okay, well, this and this type of claims lead to this and this type of validation results. And once the model is trained, then we test it with the test data so that we have then this additional column here, the machine learning model predictions. And then we sort of compare the predictions against the validation results that came with the data. And here you see like the highest one model is rejecting, whereas it was actually manually approved. The second one is the other way around. Model would approve and manually it was rejected, and then the rest is the same. And then you sort of try to understand that, okay, where do these differences come from, and evaluate the results, how accurate is the model. And then this is sort of iteration, tuning the models, tuning the data, finding these outliers or other reasons. There is a question on what machine learning algorithms did I use. I actually tried out 8 different algorithms, but the ones that in the end of the day I felt were the best was random forest and XGB booster. So that, but I would say that not drastic differences between the algorithms. There were differences, but not that big. And so, Jack, does this reflect the process that you were applying, or any major differences you see?
No, I mean, I would say, I say that is that's the process. As you mentioned, it is, I mean, it's iterative. I can't speak to what all goes into the coding and the algorithms and IT integrations, but I'd say the process is the same. What I'd want to highlight, you talked about it a little bit, Maddie, the analyze and transform. I'd even back up a step, the claim data file. I think it is so important that you know what you're putting in and how that impacts the outcome. Like I learned the hard way, I guess, that it's garbage in, garbage out. You've got to be intentional about what you want the algorithms or models to make decisions off of. It's not random. It's going to do what you tell it to do. And if you have clean and clearly defined data and know what you want in, what you want out, I mean, you'd be surprised probably about how accurate it is.
Hey, Maddie,
Exactly, yeah.
Mike Roberts here. We have one chat question. Says, what machine learning algorithm did you use? And you said 96% accuracy is great, awesome. What were some of the features?
I guess I did answer which machine learning algorithm, so that it was random forest and XGB were the ones that were like the most promising. But I did go out 8 different models in the proof of concept. These figures here, these are illustrative only, but fairly close to the actual results in the POC. And so, Zach, in the POC you did, any surprises there that you could say sort of after the fact that what did surprise you most?
Yeah, I mean, and I kind of touched on the accuracy. You know, once there's a pop up. I guess I'm getting Ian Wright's joining. The accuracy was probably the most surprising thing. Initially it wasn't, but that iterative approach that you describe is so important, and you've got to spend the time early on. I know you said you got excited, you wanted to train and test the models. The upfront work is critically important. Really that's the biggest thing for me.
What were the primary correlating predictors, the features that gave you that accuracy? That'd be interesting. Was it claim type or?
So
There
I mean,
were actually, yeah, go ahead.
I can share some of what we've done. Like the biggest thing was, for Cummins in particular, we identified that half of our claims were being reviewed by people and they weren't making any decisions. But we trained and we taught the model off of those claims as well as the ones that are making decisions, and then we took most of it, our attributes at a pretty high level, like this product line and this failure code or component code, and compared them to all the other similar claims if we had a statistically significant sample, and then every single thing that was on the claim, and there's a probability that gets assigned to every part, every labor operation, that gets rolled up, and it can make a claim level decision is how it was for us. It's like every claim attribute really, but then you would bucket them in a certain way. And I'd recommend like the product and primary failed component type level.
One thing that was
like labor, all of that type of stuff, right? Those were all attributes within that claim, right? The feature set, and there wasn't significant. Well, okay, never mind. They were all relevant. They were all predictors.
Yeah, I would say there's some in part of the data file that's in the input and the analyze and transform. You're gonna find some exclusion type scenarios probably that you don't like the outcome, and you decide that maybe this one's just too high risk, that it's not, like we have a series, like certain claims for us that meet criteria, they're excluded. We do not inference them in the model. We don't want it to approve them. But that was part of the learnings, that maybe it's a certain dollar threshold or a high TNF repair, that there's a lot of different factors that go into the decision that maybe aren't captured in the claim. I mean, there's a number of those scenarios that you may want to like implement guardrails.
One sort of thing that was for me very, very difficult was that whether the claim position was the source for error or not had a huge amount of inconsistencies there, so that I had a big amount of changes, and in some claim the source for error, yes, was changed into no, and in some claims from no into yes, and nothing else changed, and I couldn't sort of figure out, and in many cases the client couldn't figure out that, okay, what is now the sort of the basis for the decision was outside of the claim data, because the same data got into different conclusions, and that's of course very difficult for the machine learning model.
And we have another question in the chat said, is this guided machine learning? For example, you define the claim parameters in advance to generate the model?
Yes, it is guided, or in that sense that there is the claim and there is the validation result, and that is used as training the model. If I understood correctly the question. I guess we need to move on a bit. Pam, how many minutes do we still have? 4 minutes or what?
Yes, approximately.
Yeah, so still, Zach, takeaways, lessons learned, or advice you would give to other companies considering moving into this? Was the decision to move from the POC to implementation easy for you?
Yeah, so I'll try to answer. There's a few questions. Probably the biggest takeaway for me was you need to do a knowledge transfer and walk away with a full understanding and actual ownership. Like they need to stay with you of the models and the processes, and that may take some additional investment. Like maybe you need a data scientist, but you also need strong support in areas like IT if you're integrating with your system and going to maintain that integration for some period of time. Some advice, I'd probably recommend mapping out these processes that are across an end-to-end process. A good example for us is that, we go live 6 months later, our results start to deteriorate because there's different claims coming in. We go to retrain, and we realized we didn't have a very good grasp on the retraining process, and it took us several months to complete something that probably should take less than a day.
Right.
So I think it's really important to have an understanding and ownership at the end of the POC. My advice, I just honestly give it a shot. I think you'd be surprised. I talked about it a little bit. You need to know your guardrails and what your risk tolerance is going to be, and you've got to be willing to accept that it may, there might be some errors, and I've had to calibrate my team that it's okay. We accept that there's a couple of these claims that got paid incorrectly, but enabled us to pay these other 100 correctly, and just keep in mind that it's iterative. One mistake's not going to bankrupt your company or anything. It's not one and done. You don't have to have it perfect from the get-go. The learning and relearning and retraining is critical. You spot issues and you correct them quickly. Also, at Cummins, we have a compliance process. I'm sure that other people do. So we have a person that audits samples of our claims. We did an oversampling when we went live for these specific claims. Like we went out of our way to get them into our audit process. We've gone away from that oversampling, but that was really critical in our learning to keep this close quality loop, if you will. And the decision, man, I think that was the other question you had. It was easy for us once we instilled trust in the data, both within the group and our external stakeholders, which I think are really important, like not just in warranty, but you've got other key stakeholders within your company. You get trust across them, and I think it's an easy decision to proceed.
And in terms of this knowledge transfer, I think that it's immensely important to have the sort of the business participation in this evaluating the results, the tuning, the models, in that sense that understanding that, okay, I have a lot of questions that I can try to figure out myself, but if I do it together with the client, then sort of the understanding of why are these questions asked, how are they impacting the model tuning, how does it impact the sort of the data coming in, that sort of is jointly created, that understanding and knowledge, and in that sense it helps out in the knowledge transfer immensely. But
okay, yeah, speaking of that kind of leads into our next question, and Zach, you spoke to it a little bit, but someone's asking what would be the estimated IT investment for a proof of concept and then complete implementation, and considering we do have cloud infrastructure ready to go. And maybe instead of dollars, maybe you could reference as far as resources that you would need, because dollars are going to be all over the board. But what kind of resources would you need to pull off a proof of concept like this?
I don't know if Maddie, you want to answer the proof of concept?
Yeah, I mean, there should be someone from the IT. It would be good to have from the client someone with the data analysis, data science experience, but and then a couple of people with sort of the warranty and dealer network management experience. None of these would need to be full time, so that and the sort of the POC, that's the time and effort is the cost. Then you have investments when you go to the actual implementation in terms of the IT cost.
The only thing I'd add for us, it's similar, probably 3, maybe 4 people part-time, going through this, whether you have IT, data scientist, a business subject matter expert, and that's during the POC, a portion of their time, and then longer term, you do need dedicated resources, but I don't think it's a full-time job really for anybody, but you need IT and then the business kind of owner.
Okay, good. Thanks. One last question. We'll move on. How are you going to operationalize this? So, I mean, where do we leave this? I mean, you have the framework, you've got expertise. Talk about next steps. Leads right into your slide here.
Yeah, so next steps for the POC. Essentially, I have like the concept. I have the Python code and access to the algorithm, so that you could say I know what are the steps. The key thing is to get the claims data file, and then the other key thing is to get like the process of working together to address any issues that will come all the way from the first steps forward. So that would recommend a joint kickoff meeting maybe after I have received and seen the data file, so that which might be the first trip also on site to meet face to face. But I think that even though I feel that I have a very clear like step by step how would this go now, but still very flexible in terms of the participant or the client like expectations in terms of any adjustments to the approach. So that I think that there should be those discussions that what are the targets, how should we move on, then get the finalizing the approval and setting the key dates and start looking for the data.
Okay, I think we're gonna need to move on. I thank you very much, Zach and and Maddie. I want to bring now Paul Venditti from SAS Live, and he is going to be having a conversation with Dan Dobbs from Ford, who is a warranty analyst strategy. So please go ahead, Paul, and let me advance to the next slide.
Okay, great. So welcome everyone, and thank you for joining us. Today we're excited to explore how generative AI can improve the accuracy, speed, and scalability of the warranty process. And first I want to introduce some of the team members that are on today's call and driving this initiative. So, this is a team that cuts across automotive AI strategy, warranty processes, and includes obviously some SAS folks and Dan who has extensive Ford experience. So each of us brings kind of unique perspective and background, how we apply analytics to transform real world challenges in warranty. So my background, I'm an industry consultant, been 10 years with SAS. Prior to that, I had about 20 years with GE. And I had specific time at GE Research where we did a lot of things around knowledge management analytics for product support teams. So dealing with warranty challenges for gas turbines, washing machines, and even medical imaging equipment. So I have a lot of context there. Mike, who's kind of listening in, had a couple decades with SAS, and he really works with automakers, use AI and analytics across a lot of different use cases. Troy Heidemann, who's on the call, has really had his whole career built around global reliability, cutting warranty costs and boosting customer satisfaction. Sar Mishra, who's not on the call, unfortunately, he leads our product strategy within the industrials and IoT division, and he's really the driving force around this generative AI proposed solution I'll be discussing today. And again, this is a solution that's, we're demonstrating it with some customers today. It's going to be GA in the third quarter is our target. And then most importantly, with 30 years of experience at Ford, Dan, has led everything from the F-150 launches to global warranty strategy. He saved millions of dollars, driving continuous improvement, turning, data into real world results for dealers and customers alike. So that's a little bit about who we are and supporting kind of this activity that we're going to share with you. Now let's jump to the next slide, Pam, get into high level. I want to make sure we frame the problem before I get into what we're talking about from a use case. So the challenge that we're targeting is really the vast amounts of siloed, unstructured data. A lot of enterprises have a lot of text documents spread across the organization. And this is what complicates, decisions and error rates on, responding to claims. So warranty teams obviously get overwhelmed by all these disconnected, fragmented systems, and there could be things ranging from manuals to handwritten notes to technical bulletins. So there's a wide variety of content. And the challenge that we're also targeting here is that person that's in this picture. Their ability to interpret and act on AI-driven insights is one of the keys for success or failure. And that's what we're targeting with this advanced Gen AI solution. Next slide. So costs, like if we look at industry resources, warranty costs can range, anywhere from 1.5% to 5% of annual revenue in automotive industrial manufacturing. This is billions of dollars in losses. And so obviously the other thing is countering this is the automotive companies. There's a pressure to balance quality, customer satisfaction, financial health, and an ecosystem and supply chain issues. But rather than me telling you about it, let me turn it over to Dan, let him kind of share his perspective on the real costs that folks are facing here.
Yeah, thank you. One of the aspects we talked about before the session was what are the real impacts? I mean, I come from a Six Sigma background, so the hidden factories are always on my mind because in the warranty space, there's a lot of them. So from that standpoint, we spent a lot of time trying to justify the claim, and we tried to use and unfortunately use the payment system as the analytic system for the problems. So I know I'm not the only one in that space. So we spent a lot of time chasing claims. We get a lot of disparate pushback from dealers that we didn't pay properly. We also get pushback internally to say we paid too much. So in the warranty space, you're basically going to get friendly fire from all directions.
Thanks, Dan. So next slide. Let's go a little deeper. Look at the challenge now that we kind of framed, the target. And so why is this a challenging problem? I talked about the complexity. It's because there's so many different, information sources and the volume of those sources. Some of that information spanning thousands of SKUs, decades of records, non-standard documentation, and there's these diverse document collections. And really, what we want to do is extract precise, context-specific information based on the use case that might be related to a claim. And what's also kind of difficult here is that there's really complex workflows wrapped around this content that has to be accounted for. So this is, again, why this has been a hard problem to solve and why there's an opportunity with Gen AI. So how do we fix this? Let's go on to the next slide and what our approach is. So we've been, again, working on, this Gen AI concept as a key to smarter warranty intelligence. And our Gen AI strategy is really kind of predicated by, starting with kind of existing operational systems. So this could be operational claim systems in place. We got companies like, I know Mike represents Synchron on this call. Synchron has got solutions in this area around claims. That could be kind of the starting point around something we're talking about here. So our approach to this is really powered by, something we call retrieval augmented generation, RAG for short. And this is really important because what it's aimed to do is really take this disconnected, unstructured content and put it into context and support actionable insights that could be, served up to LLMs to, feed it in a consumable manner to individuals. And this is, again, RAG is also really critical if you're kind of delivering grounded context-aware answers with really reduced hallucination risks. So that's the goal. We don't want to just use an LLM out of the box because then it could make up stuff. And that's kind of something that, is not, not good for, for the kinds of solutions we work on with a lot of our customers. So without getting too deep on RAG and what it is, what we built within our solution is really a pipeline flow, a framework that allows you to ingest document collections, extract that text, and that could be, simple text. It could be OCR from pictures or even from tables, and apply kind of that extraction method for the documents. Our pipeline also does kind of chunking embedding. This is splitting the content, the text, into logical units that convert it into what we call embeddings. This is like taking the text and making it numbers so that you can search and retrieve it more efficiently. This data is very dimensional, so this is a big compute kind of problem, but there's obviously things we've done in our solution to kind of make that efficient and cost effective as part of what we do. And the third part is kind of storing those vectors into a vector database that allows for fast interactions with a Gen AI system that I'll get into here shortly. And actually, once you kind of have that integrated RAG and you can extract that content effectively based on a claim, you can then serve that up optionally to an LLM, which can kind of make it nice and easy for people to consume. And that's what a lot of us are familiar with when we use kind of things like ChatGPT. So let's move on to the next slide so we can see how this actually works. So, what we see as kind of a vision around this is the ability to really blend traditional with Gen AI. So build this out one, Pam. So if you hit the build here. So, if we think about like traditional analytics, there's, we have solutions. SAS has a solution called Field Quality Analytics that does statistical analysis with kind of claims data and can use other data sources to kind of build analysis around emerging issue detections for warranty teams. These are kind of like traditional methods that exist. And what we're specifically talking about is combining that with the Gen AI approach. Next, Bill. Which allows us to go after these collections, these data sources that are talked about, that I mentioned earlier. They could be maintenance records, parts, claims histories, service bulletins. One more, Bill. Taking those collections and putting it through a Gen AI solution, and the name that we're going to have in the marketplace for this is SAS Retrieval Agent Manager. This is a no-code interface that allows us to run this RAG methodology to these collections, so that you can, again, get the data structured for use tied to a traditional system or as even a chatbot itself. Next, Bill. And so what we've done here is kind of built a capability that allow, through API integration, they're not dependent. It's almost like a standalone capability that can work with traditional systems, but can stand alone and tackle the problem of working with this vast amount of unstructured information. So that is a high level is kind of our capability that we're talking about with with our Gen AI solution tied to warranty claims. Next slide. So let's take a look at a real world scenario. So again, there could be triggers. We call claim. We talk about claim being a trigger, a new claim, but it could be other things too. It could be IoT. It could be diagnostic codes. It'd be a combination of those things potentially. But the trigger goes through your traditional apps, and then your traditional apps kind of get worked on by people who are like warranty reviewers or technicians. And what we've enabled on the bottom is the Gen AI of the collections of documents that can be served up like by a technician with nothing related to a claim. That's a chatbot just working with the system, or it could be triggered by the actual event, the claim itself. And by triggering it with the claim, the other thing we've built into this is the idea of a smart prompt. The users might not know what to ask the Gen AI system. So by having some context on the claim itself, we can issue a smart prompt into the systems. That's another thing that we built into our system, is being able to prompt the system to bring back the right type of information based on the type of issue it is. This is, again, a little bit of a pictorial, but now let me turn it to Dan, who, when we chatted prior, Dan had some good thoughts around how he thinks about this, in a real world scenario.
Thank you. One of the aspects we run into, and I know Mike Roberts and I come from a similar background, the data at Ford, we collect data like world champions. Connecting the data across the organization is a challenge. And unless you know where to look, you're going to get only a portion of the story. One of the elements on here, the technical service bulletins and recalls, they're in constant flux. So unless that agent or who the assessor or whomever you're relying on is up to date on all of those things, you're going to have a lot of rework and a lot of concerns. The one approach I liked about this is calling the API with the existing systems and helping the dealer submit the claim properly before it ever gets in. For those of you that are in the warranty space, once you pay a claim in certain states, that's a problem. Going back and making any claim on that, as far as process-wise, is going to be expensive and time-consuming, and you're probably not going to be able to do it. So learning the policy, I worked with the AI bots here recently. It's great. The policy documentation, the parts, the bulletins, if you can roll all that together and work that into your model and put that up front into the dealer, you're going to actually cut back on a lot of the claims that you have to review because they're proper.
And one of the things that I think I mentioned was the fact that the way we've organized this is each of those things that you're seeing in the lower left, the collections, documents, they're processed with the RAG methodology by collection itself. Why is that important? Because each collection might have its own security. Certain people might need to be the ones that access that from a data security perspective. So V can stand alone, they can be processed, but then obviously the use cases, as Dan's just started alluding to, might need one or more of those collections to be synthesized in order to create a smart response for the user, the use case. So being able to have responses cut across the collections is a function of, workflows. So workflow is still a very important idea that we also have that's not really covered in this vision here that you're seeing on the slide, but we do see that as we work on use cases and pilots around this, we do see within our framework the ability to build agents that might orchestrate workflows that could be based on the type of claim or issue, can work across collections and bring back, again, the right information from the combined sources, as well. Anything else you'd like to add on that, Dan, or is it?
No, I think that, and I guess I didn't say it correctly. The front end and the back end are both going to benefit from that kind of an approach, because the assessors are a sunk cost. If you can eliminate them to, as Zach mentioned earlier, this is a claim we should look at. These are claims we shouldn't look at. So if you can bring both sides of that to the upfront and to the back end, you're going to be more efficient and ultimately easier to do business with.
So that's kind of our pilot process. Go to the next slide. And obviously, what's the impact that we're kind of, what's the summary of, I guess, the vision of it? This first is the vision of it before I get into the impact is really kind of context-rich claim summaries from day one. So being able to take this information and being able to, again, summarize that and give kind of that person that I shared the vision on in the beginning, kind of the context, some information that they can act upon. That's really the goal. And as I said, it's, we talk about claims, or we've been talking about claims as a starting point in here, but if you think about what's happening in the automotive industry with connected vehicles and the projected growth of that, doesn't have to be relegated to just claims. It could be claims, IoT data, diagnostic triple codes, et cetera, or a combination of them. So the combination of these things could be what's happening in the future. So the framework will, evolve and be able to leverage the variety of sources. And what's behind our SAS Gen AI pilot is a technology we call event stream processing. So we have a mature technology underpinning the ability to bring in, IoT based things or just the kind of documents we're talking about. So we're pretty flexible and extensible in terms of where we see this going and how this Gen AI capability can evolve over time as well. Next slide. So, what's the impact? I think if we try to quantify it, I think I heard it in the earlier call, right? The goals are try to reduce claim processing time by, say, 50%. Also improve decision accuracy on claims, 20-30%. You don't want to be shipping parts and things like that aren't really the right things to solve the problem. So being able to be accurate on decisions is also very important. And then having savings, being able to translate this into savings per number of claims. So being able to consider the workforce effort required and try to get efficiencies, operational efficiencies that drive the overall costs. And then most importantly, the customers see faster claim decisions, reviewers get better tools, and the business gains in multiple ways: reduce costs, improve fix rates, fewer escalations, and better inventory planning, is kind of the main point. And Dan, from your experience, obviously saving millions of dollars in warranty benefits, what would you like to add to that as well?
I think the key point on this one is the communication of the information that you have available. The first time fix rate, a dealer benefit, faster cycle time, dealer cash flow, reduce warranty costs. Obviously the OEM is going to benefit from that and put it back into product, so the customer experience can be better. But ultimately you can get the parts inventory planning down there, which is critical. One of the things we have is we're waiting on the claim to pay to find out about that repair. That's too late. I mean, there are inputs that you just mentioned that you can use up front, whether you're diagnostic tool, communication, log files, whatever you've got, you can understand what's going on at the dealership, and even, disposition is additional assistance to help resolve the issue to get the information, especially during launch. Everybody wants that first launch part every single time, but it may be 3 weeks out because the claim processing time. So there's a lot there that could be used and leveraged.
Great. Thank you. So would you like to be a pilot candidate? So we have a, kind of, if we're ready to put this into action, let people see it and use it. So if there's a pilot candidate interested in the call, we have this 75 days to value rollout strategy. And really it's for anyone who really wants to start small and move fast. So basically it's got, it starts with just a desert discovery call, just to make sure what we're talking about aligns. We can show the technology today, so we can do a POC demonstration, so you kind of see it in what we have and how it works. And then it's really shaping up that value, like what part do we want to target? I mean, there might be, while you targeting enterprise strategy might be too daunting, maybe there's a quick hitter within the space of data that we could use to prove that the value exists. And then obviously an NDA, some kind of data agreement, or options relative to how we get data. It could be synthetic data. We do have some capabilities around generating synthetic data, as long as it's realistic to you. That's something that we can explore. We also have the option of exploring deploying the technology on-prem if the data security is also concerned. So we've got flexibility in terms of like really figuring out how to execute this. And then obviously we can execute it because we have technology. That's a collaborative effort between you and us to kind of work through that proof. And then obviously we can share the results, point back how this worked, and see what we do to improve it moving forward. So that's kind of an outline on the POC, and that's what we had to cover today.
Are there any questions?
Yeah, there was one question about what vector database are you using? Pinecone?
So we are actually, our methodology is agnostic. Underpinning it's a lane chain framework, so we could use most any vector database, and that's generally what we're agnostic to everything. But our current ones that we're natively testing with what we're doing is Weaviate, and there's another one. I'm going to go PG Vector. So I think PG Vector and Weaviate are the two we're using today. But obviously we're agnostic. We're also agnostic on the LLM. So the LLMs, we're not doing anything fine-tuning an LLM with what we're doing here. We're leveraged to link into whatever LLM, including maybe an LLM you want to build on-prem or working with your system. So that's our focus. Yes, small language models would also be, that's one of the thoughts. Yeah, you can leverage that, because obviously then you can start getting, we do have some automotive related conversations with a lot of interest in this, where obviously on-prem is important and they're thinking about that. So that would be a benefit. And obviously it lines up really well with what we're talking about, because our data, our collections and our methodologies tied only to the data that the end client has. So again, trying to make sure we're highly accurate and efficient. And I'll also mention, since it didn't come out on cost, we're designing this to be optimized for cost. So being able to, again, be, having the embeddings and the things done so that it's compressed in a way that saves money and lower cost. That's also something we don't have benchmarks on right now, but that's something we're hoping to, validate, as well as we're doing some work in that area to try to make sure that it can be lightweight, agile, and support, architectures for deployment.
So very, very good, very thorough. Dan, something that you said, really struck a chord with me. We, within MAPconnected, we just did a research project. Pam alluded to it earlier. Looking at what tools different OEMs are using for, to support the write-up process and helping make the right warranty decisions. I hate waiting until a claim comes in, the vehicle's gone, the customer is gone. It might be 2, 3, 4 weeks later, claim comes in to say, oh, this is not a warranty repair. How, our goal, we're going to have some other follow-up discussions. Would love to get people involved in it. But how much of that decision can we drive in the write-up lane and stop a claim right there, rather than go through the whole process of, replacing the part, getting it done, customer leaves, doesn't pay, now the dealer's stuck holding the bill, or, we're fighting with the dealer over a, situation that's not even warranted. Let's drive that discussion earlier in the process. And as you said, Dan, now we have access to that information hours, days, weeks, months sooner been waiting for a warranty claim. Stay tuned for that discussion.
All right,
Thank-
well, yeah, anybody else have any other questions or comments? Thank you, Dan and Paul, for this second presentation. I have our 5 POC roadmaps up there on the screen again. As Paul mentioned, 75 days to already see, get it going and already see progress. Love to hear who might be interested in being our first. And we have August 12th as our next get together to launch the remaining 2. Please, I thank you everyone for your time. Anyone again that might be interested in joining the Technical Assistance Center exchange meetup that is going to take place in August, please let me know. And I will be back in touch with the presentations here and the recording to everyone, and also soliciting subjects and speakers for the annual summit, and we'll be sending out links so you can register your hotel and tickets for the October summit as well. Thank you, everyone, again for participating, and thank you, Zach and Maddie as well, and have a great rest of your day. Thank you. Bye-bye.
Thank you, Pam and team.
Thank you.
Bye.
Bye-bye.
Thank you.
Thank you, everyone.